Network communications and protocols. Computer communications involve long messages because networks don't do a good job of handling large chunks of data. They reformat the data into smaller, more manageable pieces called packets or frames. Networks split data into small pieces for two reasons. First, large units of data sent across a network hamper effective communications by saturating that network. Second, networks can be unreliable. If errors occur during transmission of a large amount of data, all data must be resent. Functions of packets in network communications. First is the header. The packet header usually contains the source and destination addresses of the packet, an alert signal to indicate data transmission, and clocking information to synchronize the transmission. Second is the data. The data section of a packet consists of the actual data being sent. The size of this section can vary from less than 50 bytes to 16 kilobytes, depending on the network type. The data section is also known as the payload. Third is the trailer. The packet trailer contains information to verify the validity of the packet's contents. This usually involves a cyclical redundancy check or CRC value. As mentioned in Chapter 5, the CRC value is a number associated with the packet that the sending computers first calculates and adds to the trailer. When the receiving computer gets the packet, it recalculates the CRC independently and compares the calculated value to the CRC value embedded in the trailer. If the two CRCs match, the receiver accepts the packets as undamaged. If the CRCs don't match, the receiving computer discards the packet and requests that the packet be resent. The second topic is about protocols. Strictly speaking, protocols are the rules and procedures for communicating. When people travel to other countries, they must be familiar with the proper way to meet, greet, and communicate with the locals. This need to adopt applies to computers as well. For two computers to communicate, they must speak the same language and agree in the rules of communication. Network protocols. Network protocols provide addressing and routing information, error checking, retransmission requests, and rules for communicating in some particular networking environment. The services provided by network protocols are called link services. Some popular network protocols discussed in detail later in this chapter include Internet Packet Exchange or IPX in NW-Link or Novel IPX ODI protocol. Novel's protocol and the Microsoft implementation of Novel's protocol, respectively, for packet routing and forwarding. Windows 95 and Windows 98 identify this protocol explicitly as the Novel protocol, while Windows XP and Windows 2000 and 2003 Server include NW-Link as all are part of the same protocol's name. NetBEUI, a network protocol developed by IBM and Microsoft specifically to provide transport services for Network Basic Input or Output System or NetBIOS. Note that NetBEUI does not actually provide the network layer addressing the routing information but works primarily at the transport and data link layers of the OCI model. Internet Protocol version 6 or IPv6, a new version of the ubiquitous Internet Protocol that is being implemented on many networking devices and operating systems. This new version addresses some of the weaknesses of the original IP. Transport protocols. Transport protocols handle data delivery between computers. Recall that connection-oriented transport protocols ensure reliable delivery, whereas connectionless transport protocols provide only best effort delivery. Some of the most widely used transport protocols are Transmission Control Protocol or TCP. The TCP or IP protocol responsible for reliable delivery of data. Sequence Packet Exchange or SPX and NW-Link, the Microsoft implementation of SPX, Novell's connection-oriented protocol used to guarantee data delivery. NetBIOS or NetBEUI. NetBIOS establishes and manages communications between computers. NetBEUI provides data transport services for such communications. Application protocols. It operates at the upper layers of the OSI model and provide application-to-application services. Some of the more prevalent application protocols include Simple Mail Transport Protocol or SMTP. A member of the TCP or IP protocol suite responsible for transferring email. File Transfer Protocol or FTP. Another member of the TCP or IP protocol suite used to provide file transfer services. Simple Network Management Protocol or SNMP. TCP or IP protocol used to manage and monitor network devices. Network Core Protocol or NCP. Novell's client shells and redirectors. AppleTalk File Protocol or AFP. Apple's Remote File Management Protocol.
Putting data on the cable. Access methods. Given that computers communicate in a number of ways, some factors must be considered in network communications, including how computers put data on the cable and how they ensure that the data reaches its destination undamaged. These channel access methods provide additional assurance that the data reaches its destination by preventing two or more computers from sending messages that might collide on the cable. Major access methods. Channel access is handled at the Media Access Control or MAC sublayer of the data link layer in the OSI model. There are 5 types of channel access. These are contention, switching, token passing, demand priority, and pooling. Let's define contention. Have you ever attended a meeting without a moderator? Effective communication is difficult in such a situation because everyone talks at the same time. CSMA or CD. Carrier sends multiple access with collision detection or CSMA CD is one of the most popular ways to regulate network traffic. Used by Ethernet, this access method prevents collisions by listening to the channel to see if another computer is sending data. CSMA or CA. Carrier sends multiple access with collision avoidance. CSMA CA is another channel access method that uses carrier multiple access. Switching. When network interconnect individual modes through a special device called a switch. The switch itself controls access to the media. This method of channel access control is called switching. Contention occurs on a switch only when two or more senders ask to reach the same receiver simultaneously, or when the number of simultaneous transmission requests exceed the switch ability to handle multiple connections. Token passing. Chapter 2 discussed token passing as a function of the ring topology. Using this channel access method, a special packet called the token passes sequentially from one computer to the next. Only the computer holding the token can send a data. A computer can keep the token only a specific amount of time. If the computer with the token has no data to send, it passes the token to the next computer. Demand priority. It is a channel access method used solely by the 100VG AnyLAN 100 Mbps Ethernet standard IEEE 808.12, discussed in more detail in Chapter 7. Pooling. It is one of the oldest ways to control the access to the network. A central controller, often referred to as the primary device, as each computers, the secondary device, on the network if it has data to send. If so, the computer may send up to a certain amount of data. Then it is the next computer's turn, as shown in the figure 6 to 14. That's all.